Java 17 has landed, bringing with it a wave of excitement in the developer community. With new features like records, sealed classes, and pattern matching, the language appears to be evolving. But is this evolution enough? Today, we'll dive deep into what these features actually mean for everyday coding and whether they truly address the core challenges Java developers face in the real world. Let's start by setting the stage. Java has been a staple in enterprise development for decades, but every new release brings both hope and skepticism. Java 17's headline features, records, sealed classes, and pattern matching, promise to modernize the language. On paper, these additions sound impressive and are often highlighted in conference talks and release notes. But what do they actually change for developers working on large, complex systems? Are these features revolutionary, or are they simply helping Java catch up with other languages on the JVM? Let's break down each feature and see what's really new. Records are Java's answer to boilerplate data classes. With records, you can declare a class that automatically gets equals, hashCode, and toString methods, making your code cleaner and more concise. This is a welcome change for developers tired of writing repetitive code. However, while records reduce some of the ceremony, they don't fundamentally change how you model data in Java. The core experience of building and maintaining large codebases remains largely the same. Sealed classes allow developers to control which classes can extend or implement a superclass. This brings more safety and clarity to your code, especially in large systems where inheritance hierarchies can get out of hand. By explicitly listing permitted subclasses, sealed classes help prevent accidental or unwanted extensions. Still, while this adds a layer of control, it doesn't solve the deeper issues of complexity and maintainability that often plague enterprise Java projects. Pattern matching is another highly anticipated feature in Java 17. It simplifies code that checks the type of an object and extracts its value, making conditional logic more readable and less error-prone. While this is a step forward, it's worth noting that pattern matching has been a staple in other JVM languages for years. Java is, in many ways, playing catch-up rather than breaking new ground. Despite these new features, many developers feel that Java's modernization is mostly cosmetic. The language looks more modern, and some tasks are easier, but the fundamental experience of writing and maintaining Java code hasn't changed much. The same old challenges, verbosity, complex frameworks, and slow evolution, still exist. So while Java 17 looks impressive in release notes, the day-to-day reality for developers remains largely unchanged. In the enterprise world, Java is everywhere. But when you start a new project on a Monday morning, the struggles are familiar. Large teams, growing systems, and tight deadlines mean that even with Java 17's new features, the core pain points remain. Developers still face the same hurdles they did years ago, and the language's evolution hasn't fundamentally shifted the enterprise coding experience. The unsettling reality is that Java 17's features are more about keeping up with other JVM languages than pushing the boundaries. Languages like Kotlin and Scala have offered similar capabilities for years, and Java is only now integrating them. This means that, while Java is modernizing, it's not necessarily innovating. Developers looking for groundbreaking changes may find themselves disappointed. Let's take a closer look at records. They're designed to reduce boilerplate and make data modeling simpler. But in practice, records are limited to immutable data structures and don't address the complexity of business logic or domain modeling. For many enterprise applications, the real challenge isn't writing data classes, it's managing dependencies, business rules, and system interactions. Sealed classes offer more control over inheritance, which can help prevent accidental misuse of APIs. However, they also introduce new constraints that developers must manage. In large codebases, these constraints can sometimes make refactoring harder, not easier. The promise of safety comes with the cost of increased mental overhead and stricter design decisions. Pattern matching makes code more readable and less error-prone, especially when dealing with complex type hierarchies. But its impact is incremental. It doesn't fundamentally change how you structure your applications or solve architectural problems. For developers hopping for a paradigm shift, pattern matching is a nice addition, but not a game changer. The real problems in Java aren't solved by records, sealed classes, or pattern matching. Developers still wrestle with verbose syntax, complex frameworks, and the need for discipline to write clean code. Java's safety features often come at the cost of increased complexity, and every new abstraction can dilute intent. The language's evolution is slow, and many of its challenges are deeply rooted in its design philosophy. Every new framework in Java promises simplicity, but often adds another mental model for developers to learn. This can lead to framework fatigue, where the sheer number of tools and abstractions makes projects harder to understand and maintain. While Java 17's features help, they don't address the underlying issue of cognitive overload in large systems. Java still asks developers to earn safety and clarity through discipline, rather than offering them by default. While new features provide more tools, they don't eliminate the need for careful design and consistent coding practices. In many ways, Java's evolution has made the language more powerful, but also more demanding on its users. Every abstraction added for safety can dilute the original intent of the code. As Java grows more complex, developers must juggle more concepts and frameworks, making it harder to keep codebases clean and understandable. This is a challenge not unique to Java, but it's one that the language's slow evolution has made more pronounced. Other JVM languages like Kotlin and Scala have long offered features similar to those in Java 17. These languages are often seen as more expressive and less verbose, making them attractive alternatives for modern development. Java's slow pace of change means it's often playing catch-up, rather than setting the standard. Kotlin and Scala have set the bar for modern JVM development, offering concise syntax, advanced type systems, and powerful pattern matching. Java's new features are welcome, but they don't close the gap entirely. Developers looking for a more modern experience may still prefer these alternatives. Despite its challenges, Java remains the language of choice for many enterprises. Its stability, ecosystem, and long-term support make it a safe bet for large organizations. However, the slow adoption of new features means that many teams are stuck with older patterns and practices, limiting the impact of Java 17's improvements. Most enterprise Java projects are built on legacy codebases that predate Java 17. Integrating new features into these systems can be difficult, and many teams are hesitant to adopt changes that might introduce instability. As a result, the benefits of records, sealed classes, and pattern matching are often slow to reach real-world projects. In practice, records are most useful for simple data transfer objects and API responses. They make code cleaner and reduce boilerplate, but their impact is limited in complex domains. For business logic and domain-driven design, traditional classes and interfaces are still the norm. Sealed classes shine in situations where you need strict control over inheritance, such as modeling state machines or finite sets of operations. They help prevent accidental misuse, but their strictness can be a double-edged sword, making some refactoring tasks more challenging. Pattern matching is most helpful when working with complex type hierarchies or when you need to extract data from objects in a type-safe way. It streamlines code and reduces errors, but its benefits are most noticeable in specific scenarios, rather than across the board. Many developers appreciate the new features, but there's a sense of disappointment that they don't go far enough. The core frustrations of Java development, verbosity, slow evolution, and complex frameworks remain. While Java 17 is a step forward, it's not the leap many were hoping for. Community responses to Java 17 are mixed. Some developers praise the improvements, while others point out that the language is still behind its competitors. Discussions often focus on the need for deeper changes to the language and its ecosystem, rather than incremental updates. Java's focus on safety often comes at the cost of increased complexity. Every new abstraction or feature adds another layer for developers to understand and manage. This can make Java projects harder to maintain, especially as they grow in size and scope. As more abstractions are added to Java, the original intent of code can become harder to discern. Developers must navigate multiple layers of frameworks and patterns, which can obscure the purpose of individual components. This is a common challenge in large, mature languages. Java's ecosystem is rich, but also complex. Each new framework or library promises to make development easier, but often adds its own set of rules and conventions. This can lead to confusion and increased onboarding time for new team members. As Java projects grow, developers must juggle multiple mental models, from the language itself to various frameworks and libraries. This cognitive load can slow development and increase the risk of errors, especially in large teams. Java's design philosophy emphasizes discipline over defaults. Developers are expected to follow best practices and design patterns to achieve safety and clarity. While this approach offers flexibility, it also places a heavy burden on teams to maintain code quality. There's a constant tension in Java between safety and simplicity. Features that make code safer often make it more complex, while efforts to simplify the language can reduce its expressive power. Finding the right balance is an ongoing challenge for the Java community. Java 17's features are incremental improvements, not revolutionary changes. They make some tasks easier and code cleaner, but don't address the deeper issues that many developers face. For those hopping for a major shift, these updates may feel underwhelming. Java's new features help it catch up to other JVM languages, but they don't set it apart. Developers who have used Kotlin or Scala may find Java 17's updates familiar rather than exciting. The language is modernizing but not leading the way. For Java to truly move forward, deeper changes are needed. This includes rethinking its approach to verbosity, simplifying its ecosystem, and making safety features more accessible by default. Only then can Java hope to address its real enterprise challenges and remain relevant for the next generation of developers. The path forward for Java involves balancing innovation with stability. The language must continue to evolve, but also remain true to its strengths: reliability, scalability, and a vast ecosystem. By listening to the needs of developers and embracing meaningful change, Java can continue to thrive. The Java community is vocal and passionate. By listening to developers and incorporating their feedback, the language can become more responsive to real-world needs. This means prioritizing features that address everyday pain points rather than just adding new syntax. Java's ecosystem is one of its greatest strengths, but it must evolve alongside the language. Simplifying frameworks, improving documentation, and fostering interoperability with other JVM languages can help make Java more attractive to new and experienced developers alike. Improving education and onboarding for new Java developers is essential. Clearer documentation, better tooling, and more accessible learning resources can help reduce the barriers to entry and make the language more welcoming to newcomers. Modern development relies heavily on tools. Java's tooling has improved over the years, but there's still room for growth. Investing in better IDE support, build tools, and debugging capabilities can make a big difference in developer productivity and satisfaction. The open-source community plays a crucial role in Java's evolution. By encouraging more contributions and fostering collaboration, Java can benefit from a wider range of perspectives and innovations. This helps ensure the language stays relevant and responsive to changing needs. True progress in Java will come from looking beyond syntax and focusing on the overall developer experience. This means addressing pain points in project setup, dependency management, and deployment, as well as making the language itself more expressive and enjoyable to use. The future of Java depends on its ability to adapt and innovate. While Java 17's features are a step in the right direction, more significant changes are needed to keep the language competitive and relevant. By embracing feedback and focusing on real-world needs, Java can continue to be a powerful tool for developers. In summary, Java 17 brings useful features like records, sealed classes, and pattern matching, but these are not the future of Java. They help the language catch up, but don't solve its core problems. The real work lies ahead in making Java simpler, more expressive, and better suited to modern development challenges. For Java to remain a top choice for developers, the community and language stewards must focus on meaningful improvements. This means listening to feedback, prioritizing developer experience, and making bold changes when necessary. The future of Java is in the hands of those who use and shape it every day. Developers want a language that's powerful, expressive, and easy to use. They want tools and frameworks that simplify their work, not add to their burden. By focusing on these goals, Java can continue to evolve and meet the needs of modern software development. Java's journey is far from over. While Java 17's features are a positive step, they're not the final destination. The language must continue to adapt, innovate, and respond to the needs of its vast community. With the right focus, Java can remain a cornerstone of enterprise development for years to come.